Okay, guys, in this section, complex rational expressions is the topic. The goal is to simplify, fractions with other fractions in the numerator and denominator. That's what we mean by complex rational expressions. We have fractions within fractions. And here's the good news. You already know one method for simplifying these things. Method one, we're going to use division. So when you have single fractions, so I'm talking about little fractions. I distinguish the little fractions. So look at this example down here. You got one big fraction defined by the big division bar, right? Okay, so what I do then is I say you've got the big fraction that I just circled, and then you got little fractions. Here's the numerator. The numerator itself is a fraction, so I call that a little fraction. The denominator itself is a fraction, so I call that a little fraction. So just so you know what I mean when I say big fractions, there's going to be one big fraction, usually. And then you could have multiple little fractions within that big fraction. Okay, so method one, use division. When you have single fractions, little fractions, in the big numerator and big denominator of the big fraction, simply flip and multiply the big denominator times the big numerator. It's very technical mathematical language. No, it's not, right? Little fractions, big fractions. But I think it conveys the idea. And then you're going to factor and simplify. So look, in this problem, we have this numerator, which is a fraction, divided by this fraction. So what we're going to do is just write this as a division problem. Or think of it as a division problem and then flip and multiply, really. So the good news is you've seen this kind of problem already. All right, so here's how I'm going to do. I'm going to work one step to the right since I have more room to the right. Actually, I'll put it way up here. So I'm going to leave the big numerator alone, x squared plus 7x, so that fraction in the big numerator of the big fraction, leave it. X squared plus 7x plus 10, x squared minus x minus 12. And then I'm going to take this denominator, which is a fraction itself, and flip it and multiply. So I get x squared plus 7x plus 12. This denominator I get on top. This numerator I get on the bottom. So I flip it. And on the bottom here, I get x squared minus 5x minus 14. And now it's a problem from a previous section. Remember what you do? You factor everything, divide out like factors, and then multiply at the end. Remember that? That's what we talked about yesterday. So more practice with factoring. You see x squared plus 7x plus 10. Question? Let me put it to you in the context of a problem you're familiar with. So let's say you had 3/4 and you were dividing by 5/2. And that's the same thing as 3/4 divided by symbol 5/2. How do you do that? You flip this guy, you write it as a multiplication problem. You take the guy in front, 3/4, you don't change it. You flip this guy and multiply. Remember that? Same thing. It's really helpful to think in terms of numbers when you get confused on what you're doing. Okay, so break it down to a similar problem with much simpler, perhaps numerical numerators and denominators. Okay, so that's why we're doing that. Okay, and then factor everything. So x squared plus 7x plus 10. The good news is there's a 1 here, so it's very systematic trinomial. First terms, unfoil it. What do you get? So plus 2 and plus 5. X plus 2, x plus 5. Okay. Denominator, the left-hand denominator, same situation. Very straightforward, trinomial. You need two numbers whose product is negative 12 and whose sum is negative 1. So I always get the numbers first without the signs, the absolute value of the actual numbers perhaps. And then I need a minus 1, so one of them has to be, it's got to be a minus 12 in the end. So one of them has to be minus, right? Which one? So that they add together to be negative 1, right? Multiply to make negative 12, add together to be negative 1. Okay. How about the right-hand numerator? X plus 4, x plus 3. And the right-hand denominator. So two numbers whose product is negative 14 and whose sum is negative 5. Well, okay, I think 2 and 7, and then I think one of them's got to be negative. So can I get their difference to be a negative 5? Got to be a minus 7 and a plus 2. So notice that factoring is just a small part, or a bunch of small parts of this problem, right? Of a much bigger problem. Any questions on that? Okay, now if there is a fun part, this is it. No, it's not the dark side. Everything's multiplication. This is the light side. Okay, what can we slash out? What's really happening when you do this? It's division, right? X plus 2 divided by itself makes 1. It's like saying 10 over 10 is equal to 1. 10 divided by 10 is equal to 1. When you take out x plus 2, you're dividing x plus 2 by itself. Okay, what else? Anything else? Okay, so this guy will divide out with this guy, right? Anything else? Oh, darn it, that's it? All right, so then whatever's left, you have to multiply numerator times numerator, denominator times denominator, right? So what do we get? X plus 5 times x plus 4 divided by x minus 4 times x minus 7. And then there's no reason to multiply out. Just leave it. It's just more work to multiply it out, and it doesn't do you any good. So that's it. That was method 1.